I'd like you to think back for a moment. When was the last time you or someone on your crew worked in a tree that put you closer than 10 feet from an electrical conductor? I'll bet it wasn't that long ago. Trees are often found close to electrical conductors, making it necessary for tree workers, line clearance and otherwise, to have a basic knowledge of this work hazard. You know, direct or indirect contact with an electrical conductor can be fatal. Indirect contact with electrical conductors is the major cause of electrocutions in the tree care industry. Understanding the hazard and using the proper tools, techniques, and equipment enables thousands of tree workers to work in proximity to electrical hazards every day. The purpose of this video is to acquaint you with the hazard and with these tools and techniques so that you will know what to do the next time you or one of your co-workers is confronted with a tree that is in close proximity to the wires. The National Arborist Association has produced this video program to familiarize tree workers with the special hazards involved with working in proximity to electrical conductors and how these hazards can best be avoided. Electrical conductors include not only those conductors which carry electrical power, but also fire alarms, telephone cables, and even cable television. Each is energized to some degree and with potentially fatal voltage. Each must be considered hazardous. Understanding the transmission and distribution of electricity will enable you to more readily recognize this hazard and deal with it safely. Electricity is primarily measured by volts, amperes, and ohms. Voltage is the measurement of electrical pressure. Voltage causes electricity to flow through a conductor, just as water flows through a pipe. Instead of PSI, or pounds per square inch, as is the case with measuring water pressure, we measure electricity in volts. This may be expressed as kV. The K stands for kilo, or 1,000, and the V for volts. A 13,200 volt line would be called a 13.2 kV line. Ordinary house current is usually 120 volts, but may be as much as 220 volts, needed for electric appliances such as an electric stove. An ampere is the measurement of the flow of electricity. It can also be compared to water. The flow of water is generally measured in gallons per minute. The flow of electricity is measured in amperes. An ordinary house service is usually not more than 100 amps, but may be higher. It takes only 1/10 of an ampere flowing through the body to cause the heart to go into a potentially fatal spasm known as ventricular fibrillation. An ohm is the measurement of resistance to the flow of electricity. When resistance is very high in a material, that material can be used as an insulator, such as is the case with porcelain. When resistance in a material is low, electricity flows easily, as with copper or aluminum wire. The human body is also a very good conductor of electricity. Each of these three means of measurement plays a role in how one should deal with electrical hazards. Electricity comes from a generating source, as you know, and is transmitted at a very high voltage to substations, where the voltage is lowered for distribution. Transmission lines may carry 100,000 volts or more. The higher the voltage, the larger and more numerous the insulators, the taller the tower, and the greater the distance between the conductors. Insulator size, height of tower, and distance between conductors are important factors because the greater the voltage, the greater the potential is for completing a circuit. After voltage is lowered by transformers at a substation, electricity travels through distribution lines at voltages suited to the needs of the consumers and the circumstances. While residential properties don't often require more than 220 volts, property may require as much as 13,000 volts or more. A transformer on the pole reduces the voltage to the level needed by the consumer. Often, particularly in residential areas, a transformer will step down voltage and pass it on to a secondary conductor for distribution to several consumers. The voltage on distribution lines varies. Qualified line clearance tree trimmers must know the maximum nominal voltage of any given electrical conductor in order to determine the minimum safe working distance. A table of minimum safe working distances for qualified personnel is found in the Z133 Tree Care Safety Standard of the American National Standards Institute. Only the utility company can tell you the exact voltage in a system on a given day. You must be aware of the maximum nominal voltage of a system because of the greater ability of higher voltages to overcome a given resistance. This will govern how close you can actually come to an energized line. Key indicators, however, are the size and number of insulators. Remember, the higher the voltage, the larger and more numerous the insulators. Electricity can only flow when a circuit is completed. A circuit can be completed in two ways: by direct contact and by indirect contact. Direct contact occurs when you touch an energized conductor or some other energized apparatus. Indirect contact occurs when a conductive object you are touching contacts an energized conductor. This conductive object could be a limb, a tool, or a piece of equipment. Almost all electric distribution systems include a neutral wire or ground. However, a neutral wire should never be considered as safe or non-conductive. If you are in contact with an electrical conductor or a conductive object which is in contact with an electrical conductor, and you also contact some path to ground, such as a tree, the circuit will be completed and electric shock will occur. Contact between a conductor and a guy wire, as a result of a vine growing into both, or even contact by an uninsulated boom, can complete a circuit. Remember, even an insulator in a boom can fail as a result of dirt contamination or delamination. If such contact occurs, the whole unit can become energized, in which case it is not only the person aloft who is vulnerable. When the circuit is completed, a ground person touching any part of this equipment and the ground at the same time would receive an electric shock by indirect contact. Ground personnel should never touch the equipment for any reason when attached booms or tools get closer than the minimum safe work distance from an energized conductor. Remember, very often there are conductors strung on utility poles in addition to those that carry electric power. Telephone, cable television, fire alarm, and others such as streetlights. Although the voltage may normally be less than that which is carried by a transmission or distribution line, any one of them may be hazardous and contact must be avoided. A fallen distribution line may have caused one of these lines to become energized far in excess of what you may expect. Even a guy wire could become energized. There are other factors to consider. Contact between circuits, known as phase-to-phase, causes a short circuit, which can result in electrocution. In storm emergency situations, fallen wires may energize a chain-link fence or other conductive installations. A fallen conductor may also be hidden by broken limbs or other debris. Obviously, electric conductors are never to be taken lightly, and direct or indirect contact is to be avoided under any circumstances. There is a common misconception that the covering on an overhead conductor is insulation. Although commonly called insulation, it is most often nothing more than weatherproofing. It only serves to protect the electrical conductor within and provides little, if any, insulation. All conductors, electric, telephone, cable television, etc., should always be considered as energized with potentially fatal voltages. Remember, conductors are often difficult to see. Before approaching a tree in an aerial lift, climbing into a tree, or even contemplating any work from the ground, locate any electrical conductors that may be involved. Plan your work operation to avoid any possibility of contact. When aloft, tie in so that if you slip or fall, you will not swing into a conductor. Safety regulations state that there shall be a minimum working distance for those trained to work near electrical hazards of 2 feet 4 inches from any line energized in excess of 1,100 volts, with the work distance increasing as the voltage increases above 15 kV. This chart specifies the minimum separation requirements based on varying voltage. For the tree worker trained to work near electrical conductors, maintaining as great a distance as possible from distribution lines provides a good margin of safety. All workers not specifically trained to work around electrical conductors must maintain a minimum clearance of 10 feet from distribution lines and an even greater distance from transmission lines as per the chart. Although electricity can represent a considerable hazard to the tree worker, thousands of trained tree workers operate safely around electrical hazards every day. Understanding the hazard and having respect for it are only two of the ingredients necessary for working safely around electrical conductors. You must use the proper tools and know the proper techniques of climbing or using an aerial lift to prune trees around electrical conductors. Electrical conductors are potentially dangerous. Any tree worker who works closer than 10 feet to any conductor must first be qualified by special training, and that training must be documented. Such special training and tree care practices around electrical conductors enables the tree worker to recognize the nominal or rated voltage of an electrical system and allows a tree worker to operate as close as 2 feet 4 inches from an electrical conductor up to 15,000 volts. This segment of the program deals with the tree care practices that allow the qualified tree worker to perform tree trimming and removal in proximity to electrical conductors safely and efficiently. Performing tree work safely while in proximity to electrical conductors can only be accomplished through knowledge and avoidance of electrical hazards. Accident prevention begins with the recognition of some basic rules of practice. These rules apply to you whether you are a climber, ground person, or aerial lift operator. Before climbing any tree, check to see where any electrical conductors are. Conduct a job briefing daily, or as often as the work situation requires, to acquaint yourself with the electrical hazards. Select the crotch and route of climb you want to use before you begin your climb. The crotch selected must be one that would prevent you from swinging into the conductors in the event that you slipped or fell. Never select a crotch that is directly over conductors. Only a wooden ladder or one made from other non-conductive materials may be used to assist in the climb. Always climb a tree on the side away from the conductors when there is any possibility of contact with them. Once crotched into a work position, check to see where all conductors are before beginning to work, and check again frequently until you are out of the tree. When there is any possibility of making contact, never work with your back to the conductors. Tree limbs are conductive materials, as are many of the tools which you commonly use, such as hand saws and chainsaws. Even non-conductive tools such as wooden-handled pole saws can become conductive when wet and dirty. Rubber gloves, rubber-soled shoes, or lineman's rubber overshoes are not to be considered insulated protective equipment. If a tree is in contact with an energized line, the sapwood is often more conductive of electricity than the outer bark. Therefore, if the tree in contact is to be removed, climbers should not be warned. No tree worker shall approach closer than 10 feet to a line energized over 750 volts unless there is a second qualified tree worker within visual or voice communication. This second tree worker must be qualified to perform an aerial rescue. In addition, knowledge of CPR and first aid is required. If a limb is in contact with an electrical conductor, it must be cut back with a non-conductive tool, such as a pole pruner, eliminating the contact before the limb is removed. The same requirement applies if there is a possibility that a limb could brush up against a conductor. If such a limb cannot be cut back, it must be roped to ensure that there will be no contact. The roping must be done so that the limb will swing away from the conductors. This can be accomplished several ways. For example, you may be able to crotch your lowering line so that when the limb is cut, it will swing away from the conductor, where it can be safely lowered by a ground person. Or you can tie a lowering line to a limb out near the end. Run the lowering line through a crotch well above, and then undercut the limb, while at the same time a ground person pulls on the lowering line, hinging the limb up. When the cut is complete, the limb will be parallel to the tree trunk, away from the conductors, and can be safely lowered. Should a falling limb come in contact with two energized lines at the same time, such contact could cause additional hazards to the workers involved, or cause the system to fail. Under no circumstances should a tree worker depend upon circuit breakers in the electrical system to prevent accidents of any kind. In the course of cutting back a limb that is in contact, the climber should exercise extreme caution so that a conductor isn't cut also. Never touch a hanger lodged on a conductor except with a non-conductive tool. If you are holding a limb while cutting it, be sure that when the cut is complete, the limb will not contact the conductors. Never cut any limb unless you are absolutely sure that you can safely control the direction of fall. Pole saws and pruners should be hung on limbs, never on conductors. Weather conditions are an important factor where electrical hazards are involved. Trees, limbs, and other objects become more conductive when they are wet. Also, wind can cause a cut limb to fall into or brush up against a conductor. Extreme caution should be used when weather conditions are not the best. Working from an aerial lift does not alter any of the rules concerning tree limbs and electrical conductors. Limbs touching conductors must still be cut back first and roped where necessary. If an uninsulated crane or aerial lift comes in contact with an electrical conductor, it will become energized. Should a person working on the ground touch any part of that equipment, electric shock will occur. Ground personnel are prohibited from touching an aerial lift device or any operating piece of equipment attached to it if the boom is in contact with the conductors, unless the operator moves the boom into a safe position and so notifies the ground worker. In the event that there is an emergency aloft and a person must get onto a piece of equipment to perform a rescue, contact with energized lines must first be broken, if such contact exists. If a fully insulated aerial device is involved, you can attempt to break contact by use of the lower controls. Proper procedures are described in aerial rescue training. Whenever a tree worker is not sure that an operation can be completed safely, it should not be attempted. Contact your electric utility. There are situations where the most highly skilled workers with the most sophisticated equipment just cannot function safely unless interfering electrical conductors are made safe by the utility. Tree workers must also consider potential damage to the electrical system. Under no circumstances should any operation take place that could cause damage. In addition to pruning and removals, other tree care operations must also take electrical hazards into account. Cabling and bracing materials are metal and are excellent conductors. No cables should be installed where there is a possibility of electrical contact during installation. The same applies to the installation of lightning protection systems. Ground operations also must consider potential electric hazards. When felling small trees, whose tops may be as high as electrical conductors, be certain that contact cannot take place. Always fasten a pull line to the top of a tree with a running bowline, and have another person pull the tree over as it is being cut. Such operations must be carefully coordinated, with one person giving the orders. Never attempt to control the direction of fall with your hands, or overestimate your ability to control the direction of fall. A gust of wind could cause the piece to fall the wrong way and into the conductors, causing the chainsaw operator to be electrocuted. Operations aloft and on the ground during storm emergencies can be very hazardous. Routine tree work shall not be performed during the actual storm, and workers doing storm cleanup should be aware of the following. Fallen conductors can energize the most unexpected items, such as chain link fences, guy wires, highway guardrails, and even fallen limbs. Always check for the location of any fallen conductors, and assume each is energized until a representative of the utility tells you that conditions are safe, and you can see that both ends of the conductor have been cut and the conductor removed from possible contact with any other energy source. Never forget that all conductors can be energized with potentially fatal electric currents. Examine every situation carefully before you begin, and be sure that every operation that you undertake can be completed safely. Remember, the life that you save may be your own.